Hi everyone. In this lesson, we are going to learn about one of the most important measures of spread in statistics, standard deviation. Before we look at any formulas, let's talk about what standard deviation actually measures. Standard deviation measures the typical distance data values are from the mean. Think of the mean as the center of the data. Standard deviation tells us how far the data values tend to be from that center. For example, suppose two classes have the same average test score. In one class, most students score very close to the average. In the other class, some students score much higher than the average, and some scored much lower. Even though the averages are the same, the second class has more variation. That class would have a larger standard deviation. So here's the big idea. A small standard deviation means the data values are clustered close to the mean. A large standard deviation means the data values are more spread out from the mean. Notice that the standard deviation doesn't tell us whether the data are good or bad. It simply tells us how much variation exists. Before we continue, it's important to note that there are actually two standard deviation formulas. The formula you use depends on where your data come from. If your data represent the entire population, we use the population standard deviation formula. If your data come from a sample, we use the sample standard deviation formula. Now, don't worry about memorizing these formulas right now. I have a separate video that shows how to calculate standard deviation by hand. For this lesson, I want you to notice the important difference between the two formulas. First, the symbols are different. In the population formula, the symbol mu represents the population mean. Uppercase N represents the population size. The symbol sigma represents the population standard deviation. In the sample formula, the symbol x bar represents the sample mean. Lowercase n represents the sample size. And the symbol s represents the sample standard deviation. But the biggest difference is in the denominator. Notice that the population formula divides by the population size. The sample formula divides by the sample size minus 1. Be careful here. This is one of the most common mistakes students make. When you are working with the entire population, you divide by uppercase n. When you're working with a sample, you divide by lowercase n minus 1. So before calculating standard deviation, always ask yourself, am I working with a population or a sample? Once you answer that question, you know which formula to use. Even though the formulas look slightly different, they are both measuring the same idea, the typical distance that the data values are from the mean. Now, let's talk about some important properties of standard deviation. First, standard deviation is always positive or zero. It can never be negative. Why? Because standard deviation is based on distances from the mean, and distances cannot be negative. Second, standard deviation equals zero only when all data values are exactly the same. Think back of the data set where every score was 5. There was no variation at all. In that situation, the standard deviation would be 0. Third, standard deviation has the same units as the original data. For example, if heights are measured in inches, the standard deviation is also measured in inches. This makes standard deviation easy to interpret. Fourth, standard deviation gets larger as the data become more spread out. More variation means a larger standard deviation. Less variation means a smaller standard deviation. And finally, standard deviation can be affected by outliers. If a data set contains unusually large or unusually small values, the standard deviation may increase significantly.